Welcome to this lecture on looking at the actual iOS-specific project layout that we have. The first file is one I've touched on already, and this is the appdelegate.cs, which is open in this window. As I said before, this is the area that the iOS operating system uses to communicate to your app. So if there are special events like audio changing hands, it will most likely pass through here. Now, I've pulled up Xcode in a separate window. I've created a blank project and I've opened appdelegate.swift. So this is a project written in the Swift programming language instead of C#. You'll notice immediately we have the same patterns. We have a class called appdelegate, a UI responder, and a UI appdelegate. Inside of Xamarin, we have a class called appdelegate, which inherits from UI application delegate. So switching between C# and Swift isn't too much of a stretch. And as a developer, I started with C#. I actually started with web things, but my first real, in inverted commas, language was C#, and I learned how to program apps using C#. I then moved on to Java for Android and Swift 2 for iOS because I wanted to learn more in depth. And I can tell you that if you stick with C#, it's a great start, and later on you'll start to recognize the patterns which will allow you to move over to Swift and Java. Okay, we have our app delegate. The next file in our list is entitlements.plist. If you want to use various iOS services like iCloud and Apple Pay, you have to ask for them inside of this file. They're usually fairly complicated permissions that you'd ask for in here, so your first apps won't use things like HomeKit and HealthKit. Then we have our info.plist, and this is a container for all of the variables that iOS wants to know about when our app is installed. It also wants to know what our main interface is, what orientations we will support, so do we want our user to rotate the screen or not, and various other properties in here. It also allows us to set our launch images, either from a catalog or from a special launch screen. We have various other things there. We can ask for background modes like audio and AirPlay. If you're making a streaming app, you would definitely want the audio section. Right, then we have something that is unique to C# and .NET in general. This is the main.cs. And if you're a .NET developer, you'll recognize this static method called main as the entry point to your application. In fact, that's what's written in the comment just above it. So your application will jump in here, initialize insights if you want to use it. We're not going to cover that. And then fire off the main UI application app delegate. So if we look at the Swift project, the application actually starts on app delegate automatically. There is no main file. So that's unique to our Xamarin platform. We're generally not going to modify that main method. So I'll just close some of these. Then we're on to main.storyboard. Now if I double click this, it's going to open it and it's going to give us a designer. And this is something I'm going to cover later on in this course. This designer allows us to separate out the graphical elements and the programmatic elements of our app. You get the same thing inside of Xcode and Swift. So I'll hit main.storyboard, and inside here we have a view controller. So if I switch back to Xamarin, we have the same idea. We have a view controller. We have this arrow on the left, which is the same as Xcode, and that is the main entry point of the application. So this arrow tells us what screen are we going to present to the user first. We have a packages.config. We're not going to worry about this right now. And finally, we have a viewcontroller.cs and a code file that is in a tree line with that. So open up viewcontroller.cs and have a look in here. We have a class, we have a bunch of methods, primary of which is viewDidLoad. So this viewController package loads when our app first fires up. This main.storyboard viewController is opened, and the code behind it, which is linked to that storyboard, is then executed. Inside of viewDidLoad, you are going to have code to make app. Generally, this is your starting point. Okay, just one or two more things to cover, and that is these folders here. We have references, and if I click that down, you'll notice Xamarin.ios features prominently. Obviously, we need that package because we're going from C# to native iOS. And this, if we right-click it, we can edit them, and we can add more references to various classes. We have components. This is the Xamarin Component Store. And if we double-click it and hit Get More Components, we can find a whole bunch of things that we can include in our apps, and they have a handy icon on the right that tells us which platforms they are good for. So Azure Mobile Client SDK is good for every mobile platform. We have packages. And packages we can install from NuGet. If you don't know what NuGet is, it's just a repository manager. We have various things in there. For example, if I looked up Google Ads, we could get a package for Google Ads. We could get a package for Play Services, etc. A common question I get is, what's the difference between components and packages? And the answer is none, really. Components is a repository that Xamarin controls, so they can actually charge for some of the components, and some of them are actually worth it. Packages, no one controls that. It's on NuGet, so anyone can upload to it. Generally, you'll try to start with components. If they don't work, you will revert back to packages, but they're one and the same thing. Right, the last folder we have is resources. We have one called images.xcassettes. This is generally going to hold your images, but it doesn't necessarily have to hold your images, so you can put them anywhere you like. We have some sets of app icons. This holds the app icons for us, and we'll cover that later on in the course. And we have a zip file for the launch screen. And this was the screen that was shown to us when we first ran our app on the simulator. If you double click it, we can open the designer and we can change things around if we wish by clicking on them. Okay, that is the iOS project structure in a nutshell. And it is very similar to the one in Xcode, with the exception of a few files and a few folders. So once you know how to do this in Xamarin, you could easily transfer over to Xcode if you wished to learn Swift too.